Hello everyone. Since you all must be aware that our lab is the pioneer of nanobubble technology. So I'm one of the PhD students working under Dr. Neelkant Nirmalkar, and my name is Shivigar. I'm a PMRF fellow in the Department of Chemical Engineering, IIT Ropar. Since our entire lab works on the nanobubble technology, it's highly important for us to characterize the nanobubbles that are present in our day-to-day samples. So to characterize nanobubbles, we use a nanoparticle tracking analysis technique, or NTA in simple words. This technique is basically based on the principle of Brownian motion. So here I'll be showing you how we inject the samples in this machine, which is called the NTA. Then I'll be showing you how it detects the sample and we get the report out of it. So as you can see, this is the sample which we'll be characterizing right now. So we take the sample using a syringe. And we inject it so that we can see the injected samples here in the plate. We push the sample slowly so that there are no bubbles in the sample, as the bubbles might hinder our characterization of the nanobubbles. Once we have injected the sample, we keep this plate here in the podium and we close it. Here basically what happens is the laser beam is passed through the sample, and in which the nanobubbles scatter the light and they are seen as the moving entities. This moving entity's motion basically is converted into their hydrodynamic diameter using the Einstein-Stokes equations. So now I'll be showing you a video how basically the characterization is shown by the software here. As you can see here, these entities are the nanobubbles, which can be seen through this machine, and the report that is generated out of this looks like that. We have got different compartments here. So first compartment basically shows the concentration of the particles, which here is 2.5 into 10 power 6. This basically shows how many nanobubbles are present there in the entire sample. This technique also shows the particles frame by frame also. So here, as you can see, this compartment shows particles per frame based on different samples. So characterization of nanobubbles is highly important for us since we are working on the stability and we are working on different applications as well. So in my case, I'm using nanobubbles, CO2 nanobubbles and air nanobubbles for electrochemical analysis of hydrogen production and CO2 utilization. So for me, it means that I need to characterize it for stability and how I can basically measure their size and concentration in the samples. That's it.